Number 1, this is the review for the calculus test, chapter 2. So, first thing it says the point 42 lies on this curve, y equals the square root of x, and q is the point. So this is your x and your y coordinates, of course. Use your calculator, or Desmos, to find the slope of the secant line PQ, correct to 6 decimal places for the value where x equals 4.01. So I'm going to take a picture of what I did online, and you can see and remember what you needed to do. So this is the table from Desmos. Remember, this is when you put in your x and your y, and we wanted it to 4.01, and so then we put the slope. So this is the y's, the change in y over change in x. The first one, of course, is undefined because it's still using the 4.2. But then down here, this is the slope. So that's what we wanted. And we wanted it correct to 6 decimal places. So 1, 2, 3, 4, 5, 6, right here. And it rounds up, so 0.24984. Number 2, it says the position of a car is given by the values in the following table. So they gave us the table. Estimate the instantaneous velocity when t equals 2 by averaging the velocities for the period 1 to 2. So this, and then for 2 to 3, this one. So I need to find a slope for the black group and then the red group. So for the black, I'm going to change in y, 37 minus 13 over 2 minus 1, which is just a 1 in the bottom. So this is 24. And then on the interval from 2 to 3, 72 minus 37 over, well, 3 minus 2 is a 1, so that's going to give me a 35. And then I need to average those two values. So 24 plus 35 divided by 2 gives me 29.5. And that's my answer. Number 3. It says a rock is thrown upward on a planet Mars with a velocity of 10 meters per second. Its height in meters is given later by this equation. Find the average velocity, so not instantaneous, average velocity over the time interval 1 to 2. So I need to figure out when I plug in a 1 what the value would be. So if I plug in 1, it's 8.14. And then if I plug in 2, my point would have been 12.56. Then I need to find the slope. So change in y over change in x. So the change in y is going to be 12.56 minus 8.14. Hear the phone ringing? And then a 2 minus a 1. And that comes out to be 4.42 meters per second. 4, continuity. Yay, this one's easy. Write an equation that expresses the fact that the function f is continuous at the number 3. So, if we write the limit as x goes to 3 of f of x equals f of 3. So the limit is equal to the value at f of 3. That's our equation. That's all you need to do. Number 5. Write an equation of the tangent line to the parabola at the point. So this is at the point. So what I need to figure out what the slope is of the tangent line. So I went to Desmos and made my table. This is my table. Of course, my point, 327, something really close on either side. See what it's going to. It appears the limit as it goes to it is 12. So I'm going to use my slope as 12. So let's put this over to the side. So slope is 12. And then I'm going to write the equation. So y minus y sub 1, which is 27, equals 12 times x minus x sub 1, which is 3. And just simplifying it, it ends up being y equals 12x minus 9. Number 6. Looking at that function, evaluate the function f of x at the numbers correct to 6 decimals. Use the results to guess the value of f, the limit as the limit of x goes to 2 of f of x. I used Desmos again, and I plugged in. And then I got 0.746512, 0.725728, 0.716174, 0.707993, 0.707195, 0.674899, 0.690261, 0.698482, 0.706225, 0.707018, 0.707107 is what I said the limit was. And that's a 7. Okay, so it's somewhere close to there, okay, because the limit as it gets closer and closer, and if you wanted to use Desmos to try to get closer than what these gave you, is I'm going to take this one, and I'm going to average them out. And that's what I get. Hey, a fun one. So if the limit as x goes to 8 of f of x is negative 10, so f of x right there, that's negative 10, and the limit is of g of x is 8, evaluate that limit. So limit as x goes to 8, that is going to be a negative 2. Number 8, you evaluate the limit as x goes to 0 of this. Well, I can't just plug in because the x is in the denominator, so I need to rationalize my numerator. So I'm going to multiply by the conjugate of the numerator. When I do the top, I need to do the bottom. So this gives me in the numerator a 1 minus x squared, because the square roots will cancel when I do it, and then x over 1 plus, or 1 times, x times 1 plus the square root of 1 minus x squared, which this becomes an x squared in the top, for x 1 plus the square root of 1 minus x squared. Well, this square and that one cancel. And so this ends up giving me 0 over 2, which is 0. So my limit is 0. Oh, I like this one. This one, when I see the function in the middle here, it's a squeeze function. Okay, using the squeeze theorem. So I want to graph a 1 is here, less than or equal to. I want to know the limit when it goes to negative 1. So I'm going to plug in a negative 1 and for my x. So this is a negative 1 squared plus 6 times negative 1 plus 6. It becomes a 1. So if this is 1 on the left side and it's 1 on the right side, well, the limit of the function, it's squeezed, it's the same on both sides. The limit has to be 1. So the limit of f of x as x goes to negative 1 is 1. Number 10, another easy one. Yay, we can plug in because this is just a polynomial and we can do substitution. So 7 times 5 squared plus 6 times 5 plus 8. We can do that because this is continuous. That equals 213. Number 12, I want you to sketch the graph, or 11, sorry, the graph of the function. I just went and put it in Desmos. Remember, the greatest integer, that's the floor function. This is what it looks like, but you need to know where it's open and closed at. So when you sketch it, you need to be able to tell me, and it's opened on this end and it's closed on that end. So that's what it looks like. Number 12, okay, the limit it goes to 2. I can't plug in a 2, it would give me a 0 on the bottom, so we need to factor. So the top factors is t minus 2 and t plus 2, and the denominator is a difference of cubes. So you're going to cube root, keep the sign, cube root. You're going to square it, change the sign, multiply, and square. And then we can reduce. So this cancels out. Now if I plug in a 2, I can do that. This gives me 4 over 12, which is 1/3. So remember to factor and reduce what you can and see if it works. Number 13. The cost in dollars of producing X units of a certain commodity is this equation. Find the average rate of change with respect to X when the production level changes from 100 to 103. So we just need to plug in 100 and 1. So when I plug in 101, I get out 6,465.08. And then when I plug in 103, I get 6,523.72. And then I need to find the slope. So that's 58.64. So it's not really the slope, but it is the slope. Average rate of change. And so that's what I get, 29.32. Approve. Now I thought you guys would not like the proofs, but you guys ended up really liking them, which I was shocked about. So we're going to go that x minus 5 is less than delta, because it's the limit as it goes to 5, which is greater than 0, because it's the distance. Then x cubed minus 125 is less than epsilon. I'm going to move down here, blue. And the bottom is going to factor as a difference of cubes. So I have an x minus 5 times an x squared plus 5x plus 25. That's less than epsilon. So this one is one of the little bit harder ones because of how it's split. So we have to say, well, we're going to take this part, x minus 5. So x minus 5, make it less than 1. And so that means that adding the 5, remember it splits, it's negative 1. Add 5, that's going to be less than 6, but greater than 4. And then if we plug in the 6 into this part, we get a 91. So the whole thing up here has to be less than 91. Let me move it. So x minus 5, well, the absolute value of it, times x squared plus 5x plus 25 has to be less than 91. Times also, just the x minus 5 on both sides. So if delta is the smaller of 1 and epsilon over 91, because we'll have to divide that out, and that's epsilon over 91, because right here, 91 x minus 5 less than epsilon divided by 91. That's where that came from. Then x minus 5 less than delta goes to x cubed minus 125. And you guys are not liking this one, I know. And this one's a harder one. You had some easier ones. This one's a harder one. So x minus 5 times x squared plus 5x plus 25 is less than 91. And then we'll multiply by epsilon over 91. Because then the 91 here is this. And I get x minus 5 is less than epsilon over 91, which is delta. So that works. I know, it's roundabout. I'm sorry this one's not fun. You won't have one like that. Alright, let's go to 15. It's a lot easier. So, again, you won't have one like 14. It is a harder one. So, if f and g are a continuous function with f of 3 equal to 3, and the limit right here of this function is equal to 3, find g of 3. So, f of 3 is 3 as well, from here. So I'm going to plug in 3 times 3 minus g of 3. And it says they're both continuous, so I know that then the limit has to equal it. So that's equal to 3. And then I can just solve. Minus g of 3 equals 3. So negative g of 3 equals a negative 6, so g of 3 is equal to 6. Much easier than the previous one. Number 9, sorry, not 9, 16. Man, I'm making all kinds of crazy things. The limit as x goes to negative 9. Well, this is a continuous function, so I can plug it in. And then negative 9 plus 9, that's just 0, so my limit is 0. Number 17, I want to state the domain here. Well, domain comes from denominators and radicals, any exclusions. So I know that 16 minus t squared has to be greater than or equal to 0. So 16 has to be greater than or equal to t squared. I'm going to take the square root. Because I took the square root, I need to flip this around, by the way. Let's flip it and then take the square root. So t is less than or equal to positive 4, but the negative side it could have been, it's also greater than or equal to negative 4. So my domain is from negative 4 to 4. Number 18, determine the infinite limit. Well, first of all, it tells you it's an infinite limit, but I'm looking for anything in the bottom. So nothing's going to cancel out, so I know I have an asymptote at x equals 0, and then also one at x equals negative 7. So my asymptote as I go to 0 on this, the graph looks at 0 like this, and it is an infinite limit because they're both going the same way, so it's positive infinity. Number 19, yay, another one. This one's a little harder. I'm going to move over and work it on the side here. So 19, I've got a 9 plus x to the negative 1 minus a 9 to the negative 1. I can't plug in the 0 because this is down here, so I need to rationalize and simplify. So this is actually a 1 over 9 minus x minus 1 over 9. I need to get a common denominator, so I need to multiply this by 9 over 9. And then the second one, I'm multiplying by 9 minus x over 9 minus x. This is going to give me a 9 over, I'm going to keep them separated just to be sure, because it may cancel out at some point. If it doesn't, then I'll put it together. I'm hoping that it does. This equals 9 minus 9, that's 0, and minus a negative x, that's a positive x, over 9 minus x. Well, that didn't do anything. And I'm going to come up here for this x in the denominator. That's just a 1 over an x. That's all that is. So this I brought as a 1 over x down here, and I'm taking care of it. This cancels out, and I get 1 over 9 times 9 minus x. And actually, you know what? I'm not going to do anything with that. I'm not going to multiply it out. And before I go any farther, I want to fix something. This was a plus. So this should have been a plus. Plus, 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 plus. And then that made this a negative. So this is a negative 1. So this is a negative right here. Now that I caught that mistake, I'm going to plug in a 0. So negative 1 over 9 times 9 minus 0. That gives me a negative 1 over 81. And that's my limit. 20. The limit as x goes to negative 4. So I'm going to go find the negative 4. 1, 2, 3, 4 is right here. Notice they're both going the same direction. So the limit is equal to negative infinity. Now, if they're going different ways, like right here at number negative 9, there's no limit. Okay, it's undefined, does not exist.